Hello! We are back to scenario 13, and this is the last one that I'm gonna do. Alright, so group of physicians, because they're fat, lazy, and wealthy, evidently. I'm pretty sure my parents would argue otherwise because they're both doctors and they've never done stuff like this. They decide that they're all going to try to lose weight. They're going to be healthy doctors. They're going to show their patients that they're great. And so they decide that they each are going to wager $10,000 on a weight loss challenge. And the one doctor who is neck and neck with another doctor for weight loss decides that he's going to pump himself full of furosemide, which is a powerful diuretic, so he loses his water weight, and then after the weigh-in, he's gonna drink all of his water back. But this doctor accidentally sets the infusion rate at 400 milligrams an hour, so that causes it to go above toxic concentrations of 25 milligrams per liter, and over 2 hours, he ends up fainting, almost ends up in renal failure until he's discovered, and consequently, he loses $10,000. That's nothing to bat at. That's the amount of money I pretty much could live off of for a whole year. I wish I could weight loss and get 50,000. That would be enough to pay for a lot of stuff. All right. So you can now see why he was probably driven to do that. So did the furosemide concentrations reach steady state before the infusion was stopped? So let's just write down some values that we have here. Let me change my color up. I like that blue. That blue, bright and bold and happy. Unlike these problems. Real life problems are sad and not so happy. So the T half-life is 1.5 hours, and I'm pulling it from right there. Volume of distribution is 8 liters. The infusion rate, 400 milligrams an hour. And the concentration toxicity is equal to 25 milligrams per liter. He was found after 2 hours. So okay, so did it reach steady state before the infusion was stopped? Well, the steady state is 5 half-lives. So we know that he spent 2 hours being hooked up to the pump. So, and we know a half-life is 1.5 hours. So those divided equals a ratio of 1.3 half-lives being spent. So did he end up reaching steady state? No, he did not. Thank God, otherwise he probably would have died. So what is the concentration after those 2 hours? What amount did this guy end up having in him that caused him to pass out, almost end up into renal failure? He probably lost his job. I'll have to look this up. I'm curious, did this guy lose his job? All right, so we're going to use the equation of that we used back here on this one, and you can find it in your you can find it right here on your pharmacokinetic equations. So that's the equation that we're going to use to find this. So this was 2 hours later, so, and the infusion was still going. There was no time for any degradation, so, right, do big T is 2 and little t is 2. The dose, the rate of infusion was 400 milligrams per hour. We have that up there. The clearance. We did not find clearance yet. So we have to go and find KE, which I have written down as ln of 2 over 1.5, which equals 0.4621 inverse hours. And then the volume of distribution we already have is 8, so clearance is equal to 0.4621 inverse hours times 8, so clearance equals 3.69 liters an hour. Okay, but none of that's important. We need to enter that into this. Actually, let me bring that all back. I'm just going to move this over here. Move this down here, and we'll just work on it over here. I'll be out of the way. 3.69 liters an hour. Okay, and then 1 minus e to the negative ke, which is 621 hours. And then he had it hooked up to him for 2 hours. And we have the same issue where big T and little t are equal. So that becomes e to 0, which becomes 1. So that disappears, not relevant. And so this is equal to 65.38 milligrams per liter. Is that above the toxic dose? Yeah, that's above the toxic dose. This guy is definitely poisoned. Fun fact, if you take an antiemetic while you're poisoned, most of the time you will end up still throwing up because your body, or you end up still getting, if you're throwing up and you have a poison, which is kind of interesting. I always found that interesting that your body is cool like that. Alright, so this one, sorry, I'm adjusting my microphone. How long after the infusion stop would it take for the furosemide concentration? So basically, we have this, we stopped it, trying to figure out when. So we found out that it's at 65 up here. When does it come back down to 25? That's what we're trying to figure out. So our concentration at time unknown is 25 milligrams per liter. So I did this wrong. I'm just going to come out and straightforward say I did something wrong when trying to figure out when I was trying to do this. So either I entered something into it wrong, but I figured it out anyway. And I will explain how. So I will take you through the wrong way that I did it, and somebody else maybe can explain, but I will show you how I redeemed myself and figured out the right answer. So I set it up all the same, 1 minus e negative 0.4621 times, that is little t, which is an x, and this will have a difference as well. So the original time was 2 hours minus x. So basically, what I ended up doing was going through this wrong, but I typed all of this into my calculator at the same time. So what I was able to do was enter in values in here for x until I got an answer that for that x that equaled 25 milligrams per liter eventually, which I found to be 2.08. So if somebody knows how to do this one, I evidently don't know how to do it properly. I unfortunately cannot show you how I did it because my notes make no sense. So yes, I would just suggest that you skip 34 and somebody else does it because that's one that I personally do not know how to do. I'm gonna try to redo it again tonight, and maybe I'll repost later on what I find. $35 and $36 are really easy. So I'm going to quickly go through those ones. You know what? I wish I could do pink, but pink is hard to see. Alright, so for 35, RO is 40 milligrams. This is what he intended. This is the intended dose he wanted to give. So concentration steady state is 40 milligrams per liter. We found our volume of distribution earlier. So we find out that the concentration steady state, if he hadn't bungled and accidentally added another 0, would have been 10.84, and that was far lower than the 25 milligrams per liter that he ended up, than the toxic dose, and much lower than the, what was it, 65.38 that he ended up giving himself. You can really screw yourself up with drugs. Alright, one last one, and then I am done for tonight. So this one is, he also intended that he get infused for an hour. What would have been the concentration rate at an hour? So the concentration steady state, let me try to find that. The concentration steady state is where is that? Why can't I find that equation? That's concentration steady state, but what did I end up doing? Oh, I see what I did. Okay. So I did this equation, but I took this and put it there. So this is been substituted. So but I miswrote it. So we want concentration at time 1 hour, which we will find in a second. So this becomes 1, so that all gets eliminated, and so we just have this portion of the equation if I did this correctly, which I think I did. So this is concentration time 1 hour, not concentration steady state. That's why I'm confused, because my notes are worse as the night gets on. And then that's times 1, so we don't need to write that in there. And then that becomes E0 because we're trying to find the, so that also becomes 1. And so that all becomes 4.0, 0.1124 milligrams per liter. But looking at this now, I think I may have used, I'm looking at this. Yes, we do. Oh, okay. Yeah, alright. Okay, cool. I did. Yeah. Looks like I did the right thing. Okay. I'm just tired. Numbers are starting to blur together. Alright, so that's the last one. The reason being is that this one is another one where here's the patient, here's the loading dose, then you find that here's the concentration steady state, but then the patient decides that they want to add some drugs, and then add some drugs, and then add some drugs, making our concentration steady state go like kind of like that, which we did not learn. We did not learn any of that. Not going to deal with it. This one, I'm going to look at and see what I did wrong. Probably, I think what ended up happening was I think I put 2 in here instead of X. So then when I found this out, I got 2.08 with 2 in there. So I'll look at that and see what that is, because if that's 2.08 for X over here, then that should also be 2.08. But I don't think it. I think I accidentally did that. So I'm gonna double check that one and hopefully have it done by tonight in a minute. Alright, that's it for tonight. Have a good one. See you tomorrow.